And so I'm inside the best online grapher. And what I have here is actually y equals x squared. I've written it fancy style. And the reason is because where you see these zeros is actually going to be important slots to fill to push the graph around and relocate it anywhere I want on the xy coordinate system. So really what you're looking at here though is y is equal to x squared. I've just expanded this squaring process here, and then I've added on something here at the end. Now, if I graph this, and I did of course, here it is in red, we get the classic baseline case parabola. Y is equal to x squared. It goes to the origin, it curves up like this. We notice a few things about this graph. One is that the y values here, if we pick a point on the graph and chase over to the y, that's the output. In fact, there is a minimum here. The minimum y occurs at the vertex, and this is an idea that you're going to see fleshed out as the chapter continues. That a parabola, when it opens up like this, has what's called a global minimum, where the output is at its smallest value. And so what happens here is we open up a world of optimization problems. And then again, when you think of optimization, you don't just think of minimum, you think of maximums too. And that would be this parabola here. Now, instead of y equals x squared, it's actually y equals negative x squared. And so really what we're doing is we're multiplying all the positive values generated by this squaring process. We're multiplying them by a negative. All these y values will flip to negative values. Let me go ahead and graph that. And so the graph gets mirrored across the x-axis. And now when you look at the outputs here, you see that it's getting increasingly negative as we go off to the left and to the right. But now there is a maximum y value here at the vertex. And so again, we are entering a realm of optimization problems. When the parabola opens down, that is when it has a negative ahead of it, then what happens is we have a maximum. So I said that I wanted to write this y equals x squared in this funky style because it turns out these are the values that can push the parabola wherever we want to push it. I'm going to put in a negative 2 here. And let me ask you, what makes this linear factor, x minus 2, what makes that quantity 0? I hope you're saying 2, because 2 minus 2 is 0. So when x is 2, y is equal to 0. And lo and behold, the vertex will be at 2, comma 0. Let me go ahead and graph this and show you that. And so we've shifted the parabola y equals x squared 2 places over, and there it is right there. The vertex is at whatever makes this 0, which is 2, and what's ever here, 2, comma 0. And so we can shift it the other direction, and that's what this graph here does. Let me ask you, what value makes this bubble 0? And you would say x is equal to negative 2. And sure enough, when we graph this, the parabola gets shifted over to the left 2 places. This particular number will shift it left or shift it right. And you realize what that shift is by asking yourself what value makes those bubbles, those quantities 0. And the same is true for this value here. Now, let me try something more dramatic. How about plus 5? We ask ourselves, what makes this 0? And the answer is when x is equal to 2. When x is equal to 2, this whole thing will be 0, and y will simply be equal to 5. And in fact, the vertex here is going to be at 2 over and 5 up, and there's the vertex. It's opening upward. Let's do the opposite situation. How about we shift it down 5? Slightly different situation. I ask myself, what makes this 0? And the answer is negative 2. So the vertex is going to be at negative 2, comma something. When x is negative 2, this whole thing is 0, and y is equal to negative 5. So the vertex is going to be at a negative 2, negative 5, and it's going to open upwards like so. So let's graph that. And so we can push the vertex wherever we want by these numbers right here. This is in fact called the vertex form. And in this particular section, 8.6, all the equations come at you in vertex form, and the game is to read off the vertex. The simplest way to read off that vertex, again, is just to ask what makes this 0, and then once you know that, you know the x value, and then of course when this thing goes to 0, you know what y is equal to. It's ever over here. So that's how you push these things around. The only thing I want to emphasize one more time is ask you, what happens if I put a negative sign in front of here? And the answer is it's going to be concave not up, but concave down. The vertex is still going to be at -2, -5. And this time it's concave down, and we have a maximum at the vertex -2, -5. So my suggestion is you hop over there to the best online grapher and you play around with this and you cement your learning, because I'm going to step into the bonus quiz now and use what I just discovered to solve both problems over there without much angst. See you there.